Hi everyone, it's Cassie. Welcome back to Math Wiz. Hopefully y'all had a good week and you're really excited. I remember the first time I learned about this topic. I was in AP Chemistry, a little late, but it was really fun and really great. So I hope you'll have as much fun with this topic as I did. So without further ado, scientific notation. So this is a super handy way to write really big or really small numbers without all the zeros. And we know how annoying it gets to write 1 0 0 0 0 0 0 0 0 0 0 0. You get the point. Really long, really not great. But what about when you write really tiny numbers? 0 0 0 0 0 0 0. Not great. We all know how that feels. So basically, instead of writing like 1 million per se, you can just write it as 1 times 10 to the 6. I'm going to show you how we get here, but first we're just going to think about it like this. 1 is our coefficient, right? And 6 is our exponent, which basically tells us how many times we need to multiply this number by 10, right? So a few examples. 10,000. That's going to be 1 times 10 to the 4. So then when we multiply 1 times 10 to the 4, that's going to be equal to 10,000. For 250,000, that's going to be 2.5 times 10 to the 5. Basically, we need to multiply 2.5 by 10 to the 5. So basically, like, you're looking at these and you're probably wondering, what is scientific notation? What does this kind of do? Basically, it's a way to write numbers as a number between 1 and 10 multiplied by to the power of 10. So you're going to notice that all these little front numbers are always going to be between 1 and 10. They can never be more, never be less. So yeah, just keep that in mind when you're writing our scientific notation so that's proper. Okay? So let me give you one more example. 0.001. That's going to be 1 times 10 to the negative 3. Now, there's something different about this one. Do you notice that negative exponent? That's new. So basically, this negative exponent tells us that this number is less than 1. The negative tells us to move the decimal to the left instead of to the right. So essentially, when it's negative, you kind of have a debt that's owed. You're making this number bigger. So you owe this 10, I guess, some money. So, because they're making it bigger for you, even though it's small. Okay, so I'm going to show you a quick trick that I think is going to be a little simpler to understand for scientific notation. So basically, let's say that you have 350,000, right? So here's our trick. First, you're going to move your decimal until you have a number between 1 and 10. So since our decimal's over here at the end, we're going to move it 1, 2, 3, 4, 5 spots, right? So you're going to count how many places you moved it. We counted 5. That's your exponent, right? So we're going to do times 10 to the 5. So now, since we moved it to the left, our exponent is going to be positive. Since we're making a big number smaller, we don't owe any debt. And this front number is essentially just going to stay that number that we made between 1 and 10. So our scientific notation for this will be 3.5 times 10 to the 5, right? Okay, so let's try another one. Let's do 48,000. So what we're going to do is we're going to move, oopsie, I did it in the wrong color. What we're going to do is we're going to move our decimal place 4 places to the right. So that means that we have 10 to the 4. And since this is 4.8, we're going to do 4.8 times 10 to the 4. So y'all getting that. Now we're going to try when we make it smaller, okay? So we're going to do 0.00, oopsie, that looks like a 6. 0072, right? So since our decimal place is in the front, we're going to move it to the back. 1, 2, 3. So we have 7.2. So we're going to do 7.2 times, since we moved it 3 to the back, we're going to do 3. But keep in mind, since we're making a small number bigger, it's going to be negative. Remember, we have a debt being owed, so it's going to be negative since we're moving it backwards. So scientific notation is used a lot in science and engineering. So I'm just going to give you some really common examples. The distance from the Earth to the sun, which may be a little picture, the distance from the Earth to the Sun is going to be about 149,600,000 million kilometers, right? But that's a mouthful. I even struggled to pronounce that, right? So an easy thing to think about it is that in scientific notation, it's going to be 1.496 times 10 to the 8 kilometers. That's probably a little easier to say and think about, right? Or, okay, this one's a mouthful. The mass of an electron, so I'm going to draw a little atom here. The mass of an electron that's kind of just hanging out there is 0.000. I'm not writing all those zeros. Just know that the mass of an electron is super, 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 super tiny in kilograms. It's like 0.00000 31 zeros, 911, right? So in scientific notation, this is going to be 9.11 times 10 to the negative 31 kilograms. So that's kind of crazy. I think we can all agree on that. It's so tiny, but also it makes sense that it's so tiny because it's such a little thing in an atom, and atoms are already super small that make up everything around us, right? So, yeah. Anyways, remember that scientific notation is a number between 1 and 10 to the power of 10. Hope y'all had a fun time and hope y'all understood. If you have any questions, comments, or concerns, leave them down in the comments. And it's super useful for big or really tiny numbers. And that's it. Fast, simple, and powerful.